The James Webb Telescope has captured something truly astonishing: lights that resemble those from a city shining from a distant 0.7 trillion miles away. This discovery has sparked interest in the possibility of life beyond Earth. The telescope zeroed in on Proxima Centauri b, the closest exoplanet to our solar system, and found strange bright lights. Could these lights be signs of another civilization? Let us explore how the James Webb Telescope uncovered these phenomena that will change our understanding of the universe. For a long time, researchers and regular folks alike have been excited to catch a glimpse of what life might look like beyond our own solar system. Any small bit of evidence that hinted at the possibility of something out there was eagerly welcomed. Then came a groundbreaking moment when the James Webb Space Telescope provided clear signs of life somewhere in space as it explored the vastness of space. This powerful telescope spotted something intriguing on Proxima Centauri b, an exoplanet far away. It noticed lights that looked similar to the lights you see in cities on Earth, suggesting the possible existence of an alien city on this distant planet. This idea has sparked a lot of excitement and curiosity among scientists. They are intrigued because this might just be the kind of discovery they've been hoping for. It suggests that there could be intelligent beings out there, organizing their societies in ways we can't yet fully comprehend. And we're just now beginning to see evidence of it. Looking at these distant city-like lights, which are a staggering 7 trillion miles away, NASA engineers are amazed and wonder how long these lights have been visible in space, just waiting for US to finally have the technology to see them. David Kipping, an astronomer at Columbia University, described the planet where these lights were found as quite complex. This is because, unlike most rocky planets that absorb sunlight and release infrared energy, this exoplanet behaves differently due to its unique relationship with its host star, Proxima Centauri. This finding by the James Webb Space Telescope highlights its importance. The telescope's ability to pick up infrared wavelengths was key in detecting the unusual thermal signature of Proxima b, which is crucial for understanding the planet's atmospheric conditions. Researchers plan to continue using this telescope to delve deeper into the atmosphere of this planet and even explore whether it might be habitable. The James Webb Telescope is particularly sensitive to infrared light, which allows it to observe what happens on Proxima Centauri b during the night. For many space telescopes, it's difficult to detect faint lights in the vast darkness of space, but the James Webb Telescope can see even the smallest glimmers of light. This makes it an ideal tool to confirm whether the so-called city lights on the dark side of Proxima b are real. The telescope can detect any man-made light in space if it falls within a very narrow frequency band, much narrower than regular starlight. Proxima b has a dynamic relationship with its star. On the daytime side of the planet, numerous solar panels capture the powerful energy of the star, and its spectral edge also reflects light. As the planet orbits around Proxima Centauri, it experiences day and night cycles similar to those on Earth, with intense heat during the day and cooler temperatures at night. The planet experiences significant temperature differences, which are largely determined by its makeup. For instance, if Proxima b lacks an atmosphere, the temperature difference between day and night would be extreme. Without the moderating effects of atmospheric gases or oceans, the day side would get extremely hot while the night side would fall into freezing temperatures. This dramatic temperature variation is a key area of interest for astronomers as it offers insights into the atmospheric composition of Proxima b. The James Webb Space Telescope, with its unmatched infrared imaging capabilities, can effectively analyze the planet's thermal emissions, providing valuable data on its atmospheric properties. Interestingly, the orbit of the James Webb Telescope around Earth matches the orbital period of Proxima b, allowing for comprehensive observations of its day and night every 11.2 Earth days. If the planet indeed has an atmosphere, the next step will be to examine its atmospheric chemistry to determine if it can support life. Signs such as the presence of oxygen, water vapor, and methane would indicate habitable conditions. If these elements are present on the planet, it would confirm its potential to support life. This requires precise capture and analysis of light passing through the planet's atmosphere, a challenging task. Although the James Webb Telescope has excellent capabilities for characterizing planetary atmospheres, it is primarily designed for other tasks. It specializes in analyzing variations in the concentrations of water vapor, carbon dioxide, and methane. While it has some limitations in detecting bonded oxygen, a crucial indicator of life, the telescope is also equipped to search for other important elements like ozone, which is a good indicator of a healthy atmosphere. As scientists consider the James Webb Space Telescope's findings, the search to explore faraway worlds grows, bringing us closer to knowing if we're alone. It's important to remember that the James Webb Space Telescope can only observe a limited number of the closest habitable worlds to Earth. For more detailed atmospheric studies, astronomers are turning to ground-based observatories like the extremely large telescope ELT, which is set to begin operations in 2028. The ELT is designed to provide deeper insights into the atmospheric structures of distant exoplanets, offering detailed and clear data on their potential to support life. Scientists are eagerly waiting for the operation of future space telescopes like the ELT. In the meantime, however, the James Webb Space Telescope remains an essential tool in our quest to explore distant exoplanets. Despite its limitations, the Webb Telescope continues to offer profound insights that could revolutionize our understanding of what lies beyond our solar system, both now and in the future. Researchers have big plans for the space telescopes of tomorrow. They want to tone down the bright glare of stars so we can get a better look at the planets orbiting them. Think of it like using your hand to block the sun on a bright day so you can see better. By reducing the starlight, these future telescopes will have a clearer view to study the faint light bouncing off distant planets. This will help them analyze the planet's atmosphere and check if it could support life, but this task isn't straightforward. Scientists will need to tell the difference between gases produced by living things and those from natural planetary activities like volcanoes. They're really committed to getting to know these far-off planets better so they can spot real signs of life and not get fooled by natural processes that look similar. The Webb Telescope is giving us a sneak peek at what these future studies might uncover. As we continue to push the boundaries of our knowledge and exploration of space, we get closer to understanding the complex universe and our place in it. Since the dawn of time, humans have wondered if we're alone in the universe. This question still drives many scientific studies today. Right now, the James Webb Telescope is out there in space, checking out different planets and moons to see if any might be home to alien life. A lot of people now think that aliens might actually exist somewhere in the cosmos, just waiting for us to discover them. To try to answer this age-old question, two American astronomers, Jill Tarter and Thomas Pearson, started a project in 1984 called the Search for Extraterrestrial Intelligence SETI. They set up a non-profit to listen for radio waves from space, because radio waves can travel really far without getting lost or absorbed. That's why they're using the Allen Telescope Array in the mountains of California, which has 42 radio telescopes just for this purpose. Despite looking for over 30 years, SETI hasn't found any radio signals that can definitely be said to come from aliens. But Jill Tarter is still hopeful. She believes that with today's technology, they might finally find something. She's even said she hopes everyone on Earth will join in this exciting search for company in the cosmos. Recently, there's been some buzz because NASA reported that the James Webb Space Telescope might have seen lights from a city on a planet not too far from Earth. The JWST is really the best tool we have for exploring space right now. It's hanging out 1 million miles away from Earth, sending back detailed info about the oldest parts of the universe. It's specially designed to pick up details that we've missed before, helping us understand how galaxies, stars, and planets form. Astronomers are making the most of the JWST's advanced tech, like its super sharp camera and special filters, to look at and understand the subtle colors around stars and planets. They rely on this telescope to learn about the physical and chemical makeup of places that are light years away by picking out certain wavelengths of light. The Webb telescope isn't just observing, it's actively searching the atmospheres of other planets for the tiniest hints of life using its unmatched ability to sift through space and time. It's already made some mind-blowing discoveries, like finding way more mass in the universe than we thought, hidden in big galaxies. This has made scientists rethink some of their ideas about how the universe started and grew. With each new discovery from the JWST, our drive to understand distant planets deepens, expanding what we know about life beyond Earth. Humanity is now using the JWST to go deeper into space than we've ever gone before. It's helping us gather information on remote worlds, providing new insights that could solve some big questions about these distant planets. 20 years ago, we barely knew anything about planets outside our solar system. But since then, astronomers have found over 4,000 exoplanets orbiting distant stars, showing just how far we can stretch our curiosity and technology. Yet NASA thinks these discoveries are just the beginning. They believe there are actually trillions of exoplanets out there waiting to be found. Scientists haven't stopped their space explorations, hoping to find places where aliens might live. Every so often, they get a hint that they might be on the right track. For instance, when the Galileo spacecraft went to Jupiter, it accidentally found a sign that might mean there's plant life out there. This was a huge deal because it was the first time we found what's called a biosignature, which in this case was the vegetation red edge VRE. The VRE looks for life in a unique way by checking how light bounces off it. With the help of the VRE, the James Webb Space Telescope is all set to uncover more about life in space, mapping out the orbits of planets that could be cozy enough for life nestled in the just right zones around their stars. When these indicators pop up, the VRE could really shake things up by pointing us toward intelligent life somewhere beyond Earth. This could kickstart an exciting phase of space exploration that digs into the unknown reaches of the cosmos. Picture this. Sunlight streams through various atmospheric layers, breaking into rays of different wavelengths, which atoms and molecules in those layers snatch up. As this process keeps going, it creates a unique spectral signature. Think of it as a special kind of fingerprint that we can read using a method called spectroscopy. There's a solid belief among scientists that when a planet gets bathed in starlight, the Webb telescope will catch that light as it sneaks into the planet's atmosphere. This bit of insight hints that the JWST James Webb Space Telescope could be the crucial piece we've been missing to figure out what the atmospheres on these distant planets are actually made of. Planets about the size of ours usually have a mix of carbon dioxide, nitrogen, and oxygen in their atmospheres. These planets could potentially support life, but the absence of stranger, rarer compounds might hint at different kinds of life forms and even advanced civilizations out there. Take chlorofluorocarbons, CFCs, for example. These are human-made chemicals used mainly for cooling in fridges and in various industries. If the JWST spots these synthetic chemicals in a distant planet's atmosphere, it would be rock-solid evidence of intelligent life beyond our solar system. Such a discovery would really expand the scope for astronomers, giving them a whole new playground to explore the atmospheric makeup of other planets and even the slim chance of civilizations far beyond the Milky Way. Thinking about life beyond Earth opens up all kinds of possibilities that go way beyond what we see and experience in terms of biology right here at home. Often, we imagine life needing a nice, mild climate to thrive. But the reality could be far more varied and extreme. Take extremophiles, for instance. These are mostly bacterial life forms that toss our usual ideas of what makes a place livable right out the window. These tough critters manage to survive and even thrive in conditions that would seem downright apocalyptic to other life forms. They can handle boiling hot temperatures of up to 250 degrees Fahrenheit and can even thrive in super acidic conditions where the pH dips below 3. Their very existence is a powerful reminder of how resilient life can be, even under the most intense and unforgiving conditions. As the search for life-supporting worlds takes new turns, the possibility of finding life in unexpected places challenges what we know about the universe. Given this, the vastness and diversity of space really suggests that our search for life out there has to be broad and comprehensive. Planets that look a lot like Earth and orbit stars similar to our Sun are great places to start this kind of research, but it's also really important to keep an open mind and consider less typical scenarios, like exploring exoplanets that circle around red dwarf stars, which are pretty common across the universe. Even though these stars aren't as bright or warm as our Sun, they offer unique settings to check out life's potential in varied environments. The longer lifespan of red dwarf stars also gives plenty of time for the slow, intricate processes involved in the evolution of life to play out. Take the TRAPPIST-1 system, for example. It features a dim red dwarf star and 7 rocky planets, much like Earth, orbiting around it. Out of these, 3 are thought to be in the habitable zone, which means they could have liquid water on their surfaces, despite being smaller and cooler than the Sun that warms our Earth. The TRAPPIST-1 star sends out a gentle light that could support life. By studying the light emitted by this star, scientists hope to unlock clues about the living conditions that might exist within the TRAPPIST-1 planetary system. After thorough research, the JWST figured out that this particular star is about 41 light-years away from us, located in the constellation of Leo, a promising spot for further investigation. Ward Howard, a NASA Sagan Fellow and the leading researcher on this study from the University of Colorado Boulder, couldn't hide his excitement about these discoveries. He mentioned that thanks to the JWST, this is the first time we've had the ability to look for planets around other stars that have secondary atmospheres similar to what we have around Earth. He stressed how crucial it is to understand these stars to really get what's going on with their planets. Among all the stars scattered across the cosmos, Proxima Centauri really stands out due to its proximity. It's only about 4.25 light-years away from the Sun, making it the closest star to Earth. This star emits only a faint glow, which is tough to spot in the dark night sky from our planet. Its dimness means any potentially habitable planets would need to orbit much closer than Earth does to the Sun to keep conditions right for life. Back on August 24, 2016, astronomers stumbled upon something really cool, a planet with 1.3 times the mass of Earth, perfectly positioned within the habitable zone of Proxima Centauri. This zone strikes just the right balance of light enough to melt ice and possibly give life a foothold. Proxima b, a fascinating planet that orbits the small red star known as Proxima Centauri, is situated a mere 4.66 million miles away from its star. This close proximity to its star subjects it to a variety of hazards that might make it difficult for life to thrive there. One major challenge is the intense solar winds from Proxima Centauri, which are powerful enough to potentially strip the planet of its atmosphere. However, despite these harsh conditions, Proxima b receives sufficient sunlight from its star, keeping the planet warm enough to maintain liquid water, a crucial ingredient for life as we know it. The close orbit of Proxima b around its star also results in a phenomenon called tidal locking. This means that one side of the planet always faces the star, receiving continuous sunlight, while the other side remains in constant darkness. This unique situation creates a stark contrast between the two hemispheres one could be basking in. perpetual daylight, while the other could be frozen in an eternal night. This is somewhat akin to the relationship between the Earth and the Moon, where the same side of the Moon always faces Earth. Despite the relatively small size of Proxima Centauri, it is still capable of emitting enough light and heat to potentially support an environment that could host life, not unlike conditions here on Earth. Are these strange city-like lights on Proxima Centauri be a sign of advanced alien life, or could there be another explanation we haven't considered yet? What do you think is the truth behind this discovery? Share your thoughts in the comments, and don't forget to like and subscribe for more.